Hello, everyone. I hope you're all doing well. So, welcome to the live collab session where we'll be covering Learning Unit 9, which is called the chi-squared distribution or chi-squared testing. I am going to take you through about 2 to 3 examples, which are going to be based on typical exam questions. The questions you see up on the screen are all from past papers itself, so it really is, again, an excellent indicator of the type of questions that you can expect. So naturally, again, there are additional videos that I had uploaded, and I'm hoping that you will be able to listen to those as well. Just extra practice in terms of this learning unit and the different types of questions that you can be asked. It's honestly one of the easier learning units, and between learning unit 8 and 9, which is where your choice comes in for this section in your paper, it is the last section of the paper. You obviously will see that this is the easier section between learning unit 8 and learning unit 9. So the good thing about this section is that it is very similar to Learning Unit 8, but less. Meaning that in Learning Unit 8, in last week's collab session, we saw that, remember the section was called hypothesis testing. We saw that in hypothesis testing, you have 5 steps that are followed. So it's the same 5 steps that I've written on the screen. It's exactly the same 5 steps that we followed under hypothesis testing. So the steps are to state out your hypotheses. Remember, there's 2 hypotheses. They're called your null and alternate hypotheses. Then you have to determine your region of acceptance and rejection. Then you calculate your chi-squared statistic in this case, and you compare your chi-squared statistic to your region of acceptance and rejection in step number 4, and then you conclude in step number 5. Now, in this learning unit, firstly, how it differs to hypothesis testing is with hypothesis testing, we were testing the validity of claims that were being made, and we want to know how valid or how true is a claim that was being made. Now, under chi-square distributions, and you'll see this when you go through the slides for the learning unit as well, here we're testing for patterns of outcome, meaning that we're testing whether your data set, and you'll see that you generally have 2 variables in your data set. We're testing whether they are, or there is some sort of relationship between the variables. So we're basically testing for patterns in the outcome of your variables. So here we're not testing how valid a claim is, but rather we're testing whether a relationship exists, or if we can pick up on some sort of pattern in in 2 variables, or if we can pick up, on some sort of pattern of an outcome. So when it comes to your hypotheses in step 1, the difference between this learning unit and learning unit 8 is that with this learning unit, you don't have to write out symbols and numbers like we wrote out under hypothesis testing, which is the first advantage, because here you literally just have to write out words, meaning your hypotheses will be written out as a sentence. There are no symbols like we saw under hypothesis testing, where you have to say mu is equal to or not equal to, or where you have to say mu is greater than equal to and then less than here, or less than equal to and greater than here, and so on. We don't have to use any symbols like we had used in hypothesis testing. So that's the first advantage. None of that. You just have to write it out as words. The second advantage is in step 2 here, which is to determine your region of acceptance and rejection. Now, under hypothesis testing, you had 3 types of tests. You had a 2-tailed test or 2-sided test, which had 2 critical limits. Then you had an upper tail test, which had 1 critical limit on the right. And then you had a lower tail test, which was 1 critical limit on the left. Under chi-square distributions, there is no 2-tail test and there is no lower tail test. So there's only ever going to be a one-sided upper tail test. So basically in step 2, when you draw up your region of acceptance and rejection, your bell-shaped curve, to determine the region of acceptance and rejection, it will only ever be this diagram, never any of the other two. So you have you have an upper tail test which has one critical limit on the right hand side. Everything less than or equal to that critical limit, this line here, is your region of acceptance. Everything greater than it is your region of rejection. So this is your step number 2. It is only going to be a one-sided upper tail test. And again, this is an advantage because you don't have to then worry about the other tests. So you don't have to worry about identifying, am I working with a two-tail test? Am I working with a one-sided upper tail, the one-sided lower tail test? It's only ever going to be one-sided and upper-tailed. Okay, then you have calculating your test statistic. Now here, under chi-squared distributions, there's multiple ways that you can calculate your chi-squared statistic, and I'm going to show you, and this is why I'm going through these 3 examples, because we're going to look at the different ways that you can be provided with information and then have to calculate your chi-squared statistic. And then step 4 is to compare your test statistic to the region of acceptance and rejection, and then conclude as normal. So for this, when you're determining your region of acceptance and rejection using the one-sided upper tail test, this critical limit here, this line, you will get its value from table 3 of your appendix. It's called the chi-squared distribution table. I will show it to you just now when we get to the examples and we start working with it. And it will only ever be a positive value. It will never be a negative value. Okay, so it's the same 5 steps that we're going to carry out under your chi-squared distributions. And again, I'm going to show you 3 different types of examples just to show you how the questions are almost the same idea. It's just that the way the information is presented will differ from example to example. So let's have a look at it. And as I said, these are all questions from past papers. So please make sure that you do pay careful attention to them, because it obviously then will prove useful in your exam in terms of how to space out your steps, what exactly to look for, how to write out your information, where marks are allocated, that kind of thing. Okay, so let's get started with this. I'm just going to clear the screen. So the first example here says, we wish to determine whether there is a relationship, and I'm just going to highlight that because this is the most important thing you're looking for. And I'm going to show you how the wording can differ as well from example to example. So when it comes to your chi-square distributions, one other thing that I wanted to mention is that your chi-square tests fall under 2 categories. The working and the methods are exactly the same. Literally, the only thing that ever changes between the two is the wording of the null and alternate hypotheses. So the first one is called a test of independence of association. And the second is called a test of equality. Okay, so hi Izzy, I hope you're well. Okay, so this is your test of independence of association, the first type of test that you could possibly come across, and the second is a test of equality of proportions. So literally, the steps are exactly the same. Honestly, there's no difference between them. Literally, the only change is the way that you word your null and alternate hypotheses. Other than that, there's absolutely no difference between the two. And it's actually also easy to determine which type of test it is, because the moment you see something like this, like the part I highlighted at the top, where it says we wish to determine whether there is a relationship between gender and the preferred insurance provider, it immediately says that if you're testing for a relationship, you are testing whether there is some sort of dependence between the two variables or whether there is complete independence between the two. So immediately it says it cannot be a test of equality of proportions. Okay, so the moment you see them mentioning anything about a relationship, or they could also possibly use the word independent or dependence and so on, this says to you that it is a test of independence of association. So just back to reading the question, and then we'll start with the actual answers. So we wish to determine whether there is a relationship between gender and the preferred insurance provider. A survey of 300 South Africans produced the following results. So they've given you the the different preferred providers here at the top, which is Momentum, Liberty, and Discovery, and then the two genders in the first column, which is male and female. So in total, there are 300 people that they're looking at here, and they ask you to perform an appropriate test at a 1% level of significance to determine whether there is a relationship between gender and the preferred insurance provider. Now, literally just from that question, we actually have got what goes into our null and alternate hypotheses. It's that easy. You can literally look at the question and it will tell you what exactly you're looking for, what exactly you're testing in your chi-squared statistic. So that's a real advantage. Again, when it comes to your chi-squared tests or distributions, it's quite straightforward. Most of the information that you need will already be provided to you. There's very little where you actually have to do work and get figures and calculate certain things and so on. So literally from that last sentence that I highlighted, we're going to put together your null and alternate hypotheses. So your null hypothesis is a general rule. Again, like when we did hypothesis testing last week, we said the general rule is that the null must always have the equal sign, whether it's equal to itself or whether it's less than equal to, greater than or equal to, as long as it has its equality sign, it must go into the null. Now here with the chi-square test, the general, no worries, no problem at all, Bradley. So again, back to this one, with a chi-square distribution, if it's an independence of association test, then your null hypothesis must always say that there is, you can either, if you're using the word relationship, you can say there's no relationship, or you can say there's no association, or you can say that they're independent of each other. So just as a general rule, and I'm just going to write it here, but I'll need to erase it just now. Just as a general rule, whenever you're working with a test of independence of association, your null will either say that the two variables are independent, meaning there's no relationship or no association between the two variables. So any one of these words can be used in your null hypothesis. Sorry, your null hypothesis. So any one of these words can be used in your null hypothesis. Sorry, your null hypothesis. The alternate will say the opposite. As always, the alternate always says the opposite of the null. So if the null says it's independent, then the alternate will say that there is some sort of dependency. If the null says that there's no relationship, the alternate will say that there is a relationship. And if the null says that there's no association, the alternate will say that there is an association. Okay, so as always, the null and alternate will say the opposite to each other, and it will always be such that the null must say that they are independent. The null can never say that they are dependent, or the null must say that there's no relationship. It can never say that there is a relationship, and the null can say that there's no association. It can never ever say that there is an association. This is just as a general rule in terms of how your null and alternate hypotheses should be stated. So in this particular example, the question, literally from that last sentence highlighted, said they want to determine whether there is a relationship between the preferred gender, between gender and the preferred insurance provider. So naturally, because we know that the null must say that they are independent, or there's no relationship, or there's no association, you will say that there is no relationship between gender and the preferred service provider. So we have made sure that it says there's no relationship, and then your alternate will say the opposite of that, which means that there is a relationship. So let's just take out the word. So there is a relationship between, I'm just going to write short form here, between gender and the preferred service provider. Okay, so that is it for your null and alternate hypotheses, and that's step 1 done. Now for step 2, which is to determine your region of acceptance and rejection. Remember, we said that it is only ever going to be a one-sided upper tail test. It is never ever going to be two-sided. It's never ever going to be one-sided and lower-tailed. So basically, when you draw this up, everything, including that critical limit, that line, and to the left of it is your region of acceptance, everything to the right of it is your region of rejection. Now, how do we determine under your chi-square tests what the critical limit is? So you need two things. You need your level of significance, which they gave to you here. They said it was 1%. Here it is here, 1% level of significance. Remember, that's denoted by the letter A, or the symbol A, and that is as a decimal 0.01. Now for your degrees of freedom. We also saw this last week, but it's calculated differently when you have this table, which, if you recall, is called a two-way contingency table. You'll remember it from Learning Unit 5. It was also in your assignment 2. So this is a two-way contingency table. And from this table, you're able to get to your degrees of freedom by taking, and this is the formula, you'll see it in your slides as well. So it's the number of rows minus 1 multiplied by the number of columns minus 1. But when we refer to rows and columns here, we're talking about the rows and columns that actually have information about your category. So for example, your category in the first heading here is gender, and there's two rows that have the categories, which are male and female. So that's two rows with your categories. And then your number of columns that have categories are momentum, liberty, and discovery. So that's 3 columns. So that's 3 minus 1. So it's 2 minus 1, which is 1, times 3 minus 1, which is 2. So 1 times 2 tells us that it is 2. So now we have your level of significance and we have your degrees of freedom. Once we have that, and again, this is where I wrote down earlier, you're going to go to table 3 of your appendix. It will be provided to you as always in your exam, so you naturally cannot learn all of those values. There's too many values. So here you're going to go to table 2. I'm just going to write down here that your chi-squared limit is, we know that it will have to be a positive value, and we're looking for A going across at the top, and degrees of freedom will be coming down in the first column. So let's pull up that. So this is also in your textbook if you'd like to have a look. It's at the back of your textbook under your appendix. You can have a look at that for an idea of what the formula sheet will look like, what the tables will look like. So remember, you're looking for A is 0.01 and the degrees of freedom are 2. So here is 0.01 and the degrees of freedom are 2. So here is 0.01, and then in the first column you have, sorry, let me just change the color of this. So here's the 0.01, and then your degrees of freedom is in the first column and your degree of freedom is 2. So that would be 9 point, in line with those. In line with 2 and the 0.01, it's 9.210. Okay, so that is it. That is now your chi-squared limit. So you'll say your chi-squared limit is 9.210. And it's as easy as that. There's literally nothing more to it. You're just going to the table, reading across for the letter A, and reading down the first column for your degrees of freedom. Okay, so let's take the 9.210 back. All right, there we go. So now in terms of the 9.210, remember you draw up the diagram for your own purposes, but it also needs to be written out as a sentence explaining your region of acceptance and rejection. So you will then say that you will accept. Generally, we only say one of them. You don't need to write out a sentence for both of them, the acceptance and the rejection region. So you'll say accept the null hypothesis if your chi-squared, sorry, I should have left a bit of space here. Let me see if I can. Okay, so accept the null hypothesis if your chi-squared statistic is, so your acceptance region is here. So if it's less than or equal to the 9.210, and then obviously your rejection region is the opposite. But you don't actually need to write out the whole of the rejection region. If you want to, if you're comfortable with, you can also say reject the null hypothesis if your chi-squared statistic is greater than the 9.210. So here it's not necessary to do both of them. There'll only be a mark allocation for one of them, and this is generally how the mark is allocated. So you'll say accept the null hypothesis if your chi-squared statistic, which we'll be calculating just now, is less than or equal to 9.210. Okay, so we're done with step 2, which is your region of acceptance and rejection. Now for step 3, which is to calculate your test statistic. So I'm going to do it at the bottom here just because I have some space here. But obviously you'll draw it up more spaciously in your answer, sorry, in your revision. But also please make sure that when you are studying, you remember to learn the templates for these tables. They are not provided to you. So like I'm going to be writing the headings here. Sometimes in the very rare occasion, they will give it to you, meaning they'll say to you, use the table below, use the format below, and draw up your table. But honestly, I would my best advice is don't bank on that. Don't bank on them giving you a starting point for anything. You should learn whatever is necessary. Wherever something is drawn up in a table, learn the format of the table. Whenever you are looking at a diagram, for example, being drawn up, learn exactly how you're drawing it, because you're not going to generally get a starting point. Okay, if you do get a starting point, obviously all well and good, but just for your own benefit so you don't mess up, please make sure that you do include make sure that you do study for this when you are, or take it into account when you're studying for this. Okay, so what we're going to do is you now have your region of acceptance and rejection, and this is your step 2 basically. So we've done step 1 at the top. I'm just going to label that step 1. Step 2 was this. Step 3 is now to calculate your test statistic. Look, you don't need to label it 1, 2, 3, 4, 5, and so on, but just for your own purposes to make sure that you are ticking off or including each step as we go along. I also, again, would suggest that you do include the number of the step that you're doing. Okay, so you're done with step number 2. Again, we're on step number 3, which is to calculate your test statistic. The first thing you're going to do is put down your categories. So that's the first thing in the table, category. Then you're going to put in FO, FE, and then I'm going to explain this in a second. So I'll explain all the headings just now. Let's do the first column first. So here it is, the category. You're going to start off with the categories as they are listed across, meaning female first, and then the momentum figure, the liberty figure, the discovery figure. Sorry, let me just change that highlight color to the green we were working with. Okay, so you're going to write them exactly in that order, but just vertically instead of horizontally. So female, you have momentum first. And all of the figures in this table at the top here that you're given, these are all the FO values. What that stands for, and you'll see it in your slides as well, and your textbook, are the observed frequencies. Okay, so your momentum figure is 12. Your liberty figure is 24. And your discovery, is 61. Okay, so you're done with the females. Now you're going to go on to the males. So exactly in that same sequence, you're going to do momentum first, then liberty, and then discovery. So I'm just going to try and squash it in here. So momentum, okay, so this is 30, 48, 125. Okay, so all we're going to do then, so we have your observed frequencies. Now, this is where the little bit of a tricky part comes in, but it's more of, I wouldn't really say tricky, it's more of you need to gauge and identify which are the values respective to your calculation. So let's do this. Let me just erase the rest of this. Okay, so go back to your table that you had drawn at the bottom. The first one that we were working with was momentum and the number 12 in the table. So here's momentum. The first one that we were working with was momentum and the number 12 in the table. So here's momentum and here's 12. All you're going to go do is you're going to take its total at the end of that row, which is 97. I'm just going to write it at the top here, 97. You're going to multiply it by the total of that column coming down here. That total is 42, so times 42. and divide it by your total sample size, which is the 300. Okay, so that is the first one, and that would tell you that your FE value, and that's what we're calculating now, your FE values, this is 13.58. Okay, so we're done with the first one. Now we can move on to the next one. Okay, so then you have for Liberty. So again, and I'm just going to erase on the table here. For Liberty, you're going to go to Liberty on the table. Here it is here for females. So in line with female and Liberty, it's 24. So just go to its row total of 97 and its column total is 72. So it's 97 times 72, and then it's divided by your total sample size, which is 300. So that would be 23.28. Then again for the next one. So let's erase that again here. Okay, so the next one is discovery, and that is, so I'm just going to go back to the bottom table. Discovery, and that's a 61 in the table. So here's discovery and 61. Here again, the total in the row multiplied by the total in that column. So 97 times 186, and then divided by your sample size of 300, and that is 60.14. Okay, and then it's the same for the last row as well. So let's look at the last row. So here you're looking at males and momentum. So here's male and momentum. In line with it, it's 30. So go to its row total times its column total. So 203 times 42, and that's divided by your sample size of 300. So this is 28.42. Then again for the next one, and I'm just showing it to you for now for all of them because I don't want you to get confused or lost. So the next one is 40. So its row total is 203. Its column total is 72. So basically 203 times 72, and then divided by the sample size of 300. And the next one is, sorry, before I move on to that, it's 48.72. And then the last one is the 125, row total 203, column total 186. And then divide that by your sample size of 300. So this is 125.86. Okay, so now you have your values for your first two columns apart from the categories heading. You now can calculate the last value in that last column. Now, why do we calculate this in a table format? So the easiest answer to that is that if you look at the formula, which is, and this is a long formula, you'll see it in your slides as well for this learning unit. The formula for your chi-squared statistic is exactly that. Sorry, guys, I seem to have got cut off there. Okay, so it's the chi-square distribution is calculated as the sum of, I'm just going to try and squash it in here, FO minus FE squared over FE. Now, if you look at this part here before the sum, after the sum of, so it says FO minus FE squared and then over FE. That's exactly the same thing that we have in this last column here. All that we're doing differently is instead of just summing them up randomly, and it is a given, it must be done in table format. There's no two ways around it. Please don't leave out the tables in your answer booklet for this question. Please make sure, don't just randomly write out figures anywhere and so on. Please do it exactly as I am showing you at the bottom here. It is absolutely imperative that you stick to this format because there are marks allocated to this table in your memos for this learning unit. Okay, so you have the last column, which is now going to give the, or where we're going to calculate the chi-squared statistic. So here you'll use that formula, you'll add up that whole column, and this is going to give you your chi-squared statistic. Okay, so all of the information you have now for that last column. So for example, for the first one, and you don't need to show the working out of this, there's no marks allocated to the working out. So it is FO, which is 12, minus FE, which is 13.58. So let's write that out. So it's 12, where can I write it out? Let's remove that. So it is FO, which is 12, minus FE, which is 13.58, minus FE, which is 13.58. And this is squared, and it's divided by the 13 point, sorry, I wrote it as 85. It's supposed to be 58. Okay, so it's FO minus FE squared over the FE. Okay, so this is going to be an answer of 0.18. You can leave these as as two decimals unless stated otherwise. But as a general norm, you can leave it as two decimals. Okay, so this is 0.18. Then you have the next one, and again, you don't have to show the working of this. I'm just going to show you the working out of like one or two more, and then we'll just put down the answers for the rest. So this is 24 minus 23.28. So 24 minus 23.28 squared over 23.28. And this is 0.02. Then the next one is 61 and 60.14. So you're going to say, just erasing that. So 61 is the observed minus 60.14 squared over 60.14. So this is 0.01. And then the rest is the same, 30 minus 28.42 squared over 28.42, that's 0.09. Then 48 minus 48.72 squared, 0.01. And then 125 minus 125.86 squared over 128.56, and that would be 0.01. Okay, so all you're going to do now is, I don't have much space, well, I don't have any space at the bottom here, but you're basically just going to put like a total in there. And when you add up all these figures, I'm just going to write it on the side, but obviously you'll show it at the bottom. That gives you a total of, the chi-squared statistic is 0.32. So now you're going to, and this is step 3, done. Now you're going to, in step 4, compare this chi-squared statistic to number 2 here, which is your region of acceptance and rejection. So here you're going to look at where does the 0.32 fall on the diagram that we have drawn up here. So remember, this is treated as a normal number line, meaning to the left, it's going further into negative values. To the right, it's going further into positive values. So the 0.32 is somewhere here. And this is naturally then in your region of acceptance. So now to conclude, finally, you're going to say that if you are accepting your null, that means that the null is true, which means that there is no relationship between gender and the preferred service provider. And it's as simple as that. Most of your information is going to come from the question with your little bits of information, like saying to you, this is, well, testing whether there is a relationship, or from the question, from the final question itself, it says determine whether there is a relationship between gender and the preferred insurance provider, and so on. Most of these questions, you'll see on the next page as well, they give you that information. They tell you that we're looking at whether there is equality, whether there is a relationship, whether there is association, that kind of thing. So it really is quite straightforward then. And to conclude, as I said, and I'm just going to write the conclusion here as well in the center here. All right, so let me just put an asterisk here. So you'll say therefore, and you will say we are accepting the null hypothesis. But remember, I said try to use the word do not reject instead of accept, because that's the preferable words that we use. So if you're saying that you're accepting, it's the same as saying do not reject. So do not reject the null hypothesis, which indicates that there is no relationship between gender and the preferred provider, service provider. Okay, so please make sure that you do it in exactly the same sequence that we had done it here. Step 4 and 5 are sort of done in one here, right? And I told you the same thing when we did hypothesis testing as well, that step 4 and 5 are sort of joined into one, because you're plotting where your test statistic falls on your diagram, and you're deciding whether to accept or reject and conclude at the same time. So here, step 4 is basically to actually say whether we accept or reject. So here, where we said do not reject the null hypothesis, that's technically step 4, but we combine it because it goes with the conclusion. So and I'm just going to highlight that in another color here. The next part, which indicates that there is no relationship between gender and the service provider, that's actually step 5. Okay, so just make note of that for your own benefit, that step 4 and 5 are combined into one, but it's just that because it is the final two steps, and they need to be in terms of to state whether you are accepting or rejection, and the reason, it needs to be as one. So you need to say whether you're accepting or you're not accepting, you're rejecting or you're not rejecting the null hypothesis, and then explain what you mean by that. And please remember, it's always about the null hypothesis when you are writing out and I'm also going to highlight this in another color. When you're writing out the region of acceptance and rejection here, the part in yellow that I'm highlighting, it's always about the null. You never ever say accept the alternate or reject the alternate, blah, blah, blah. So you always say the null, even in your conclusion, like here, and again, I'm going over the conclusion here in yellow, you never ever say accept the null, or do not reject the null, or reject the null. It's all, sorry, you never ever say it's about the alternate. You don't ever say do not reject the alternate or reject the alternate. It's always about the null hypothesis. Okay, so this is your first type of test of independence of association. Let's look at the next one on the next page. Okay, so this one says to you that the marketing manager of a soap manufacturing company wishes to know whether the three different hand soaps that they produce are equally popular. So the moment you see the word equal in the sentence, whether it's an opening sentence or the question itself being asked, it immediately says to you that it's a test of equality of proportion, literally to the word. So equally and equality, that immediately is saying to you it's a test of equality of proportion. So then it says a random sample of 900 consumers were asked to choose their favorite from the three soaps, and the results were as follows. As always, the information provided is the observed values, meaning that whatever you see in this table are your observed frequencies. So I'm just going to write here FO. Okay, then they said to you these were the values for your FO. Okay, then they said to you these were the values for your observed frequency. So, firstly, the types of soap are rose, lemon, and citronella. There are 900 people in total. There are three categories. Please make note of that, which are the flavors. Sorry, not flavors. Um, Scents, I think it is. Yes. So rose, lemon, and citronella. There's three categories here. And then they say to you, using a 1% significance level, test whether the soaps are equally popular. So once again, from the question itself, they've actually told you what goes into the null and alternate hypotheses. So the null, remember, is H0. The alternate is H1. Now, again, here, when it's a test of equality, there is a general rule. The null must say, very similar to hypothesis testing, the null must say that they are equal, meaning in this case, they are equally popular. So you're going to say literally what the sentence I highlighted at the end here said. You will say that the soaps are equally popular in the null hypothesis. The alternate will say literally the opposite, that the soaps are not equally popular. Okay, and that's it. You're done with your first step, your null and alternate hypotheses. Step two now is your region of acceptance and rejection. So when you draw up your bell-shaped curve, remember always a positively skewed test or a one-sided upper tail test. So this is one critical limit on the right-hand side. Everything less than or equal to that critical limit is your region of acceptance. Everything greater than it is your region of rejection. So again, how do we get to the critical limit? So you need A, which is your level of significance. They said 1%, so as a decimal, that's 0.01. And your degrees of freedom, now, if you look at this table, it's not a two-way contingency table. Here, it's just a normal table with information. So if you have a normal table like this, not a two-way table, then your degrees of freedom are calculated as n minus 1. N is the number of categories that you have, and we said that there were three types of soap, so it's 3 as N minus 1. So 3 minus 1 would give you a degree of freedom of 2. So now you're going to go back to the table, and we're going, sorry, table 3 of your appendix. So let's go back to that table, and we're going to get to your chi-squared limit. So let me pull that up. It's actually the same as the one we did just now. So 0.01 and 2. So it's exactly the same thing we did here. If you look at it, 0.01 is your A value, degree of freedom is 2. So on the table, we went to 0.01 here, and we went to 2 here under your degrees of freedom. In line with that, it's 9.210. So exactly the same critical limit as your other example. Let's go back here and write that down. Again, remember, you need to write it out in words. but your diagram is just for your own purposes. So this is 9.210. So you'll write down that your chi-squared limit is 9.210, but you'll also write that out in words. So you will say that you will accept the null hypothesis if the chi-squared statistic is less than or equal to 9.210. And you're done with step 2. Now for step 3, which is to calculate your test statistic. So this is again a little bit different from the one that we saw just now. And this is because this is not a two-way table. This is now a normal table that you're working with. So you're putting in the category FO, FE. Also, in terms of this table, the good thing that is that when you draw up the table, it's always the same headings. You're not going to have to learn different tables for different types of tests. It's always the same table, the same headings, exactly the same as we saw just now. Category FO, FE, and then FO minus FE squared over FE. Okay, so in the first column, you're putting in your categories, which are rose, lemon, and citronella. Literally the ones that are listed out at the top here. So they are rose, lemon, citronella. Rose is observed frequency 320. Lemon is 295. And citronella 285. Okay, so now how do we get to the FE values? Now that little bit at the top in that initial paragraph that I highlighted where it says equally popular, it's actually quite easy. When they say that they are equally popular, it means you're simply taking your total sample size, which in this case say that they are equally popular, it means you're simply taking your total sample size, which in this case, it's also in the table, the total of 900, but they also told you there's a random sample of 900 consumers. You just divide the 900 amongst the number of categories. So there's 3 categories, so you're splitting the 900 equally across the 3 categories. So your FE value then is 900 divided by 3. If there were 4 categories, it would be 900 over 4. 5 categories, 900 over 5, that kind of thing. So it's 300 for all of them. And that's it. That is literally it in terms of your chi-squared, sorry, in terms of your FE for your chi-squared statistic. Sorry, just want to erase that part at the bottom. Okay, so now you're simply going to do the normal FO minus FE squared over FE. So for instance, the first one will then be 320 is the FE value minus, sorry, FO value minus FE is 300. Square that over the 300. Okay, so this is going to be 1.33. Then the next one will be 295 minus the 300 squared over the 300, and that's 0.08, and then 285 minus 300 squared over 300 is 0.75. So this, when you add them up, is going to give you a total of 2.16. Okay, so this is it for your chi-squared statistics. So I'm just going to write down there that your chi-squared statistic is 2.16. So now in the last step, you're going to look at where does the 2.16 fall. So this would be somewhere on the right-hand side, somewhere, somewhere on the left-hand side, somewhere here. Remember, it's treated as a normal number line. So this is in your region of acceptance. Remember, we try to say do not reject instead of just outright saying accept. But if it and you just say accept, it's fine. It's not a train smash. That's perfectly fine as well. So you'll say do not reject the null hypothesis, comma, which yes, exactly. It's actually not bad at all. It's a much, much easier section than hypothesis testing. And this particular question, yes, with the equally popular bits, quite simple. So, which indicates that. So if we're saying we accept the null, you'll go back to the null and just basically you're saying you accept it, so it's true. So we're basically putting a tick here and literally just say what your null is saying to you, that the soaps are equally popular. So you'll say this indicates that the soaps are equally popular. And that is literally it. So it's quite a nice section, as you can see, not as complicated as your hypothesis testing was. Obviously, it's a little bit more work when it comes to calculating your chi-squared statistic, because you've got to draw up this table and calculate the values of calculate the FE values and then FO minus FE squared over FE. So a little bit more work there, but honestly, in terms of the fact that you have more work here, but it's an easier section versus a little bit less work there in terms of calculating the test statistic, but a lot more complication in terms of the different types of tests and identifying which test is which and when to use a different table, when you have a different sample size, and so on. It is a lot more complicated with hypothesis testing. So it's really not bad at all. It is quite straightforward. And let's look at the last example and we're done for today. So this is the last example. It's just on a separate document. So I'm just going to pull it up. Okay, so I'm just doing one more example because I just want to show you the different wording. As I said earlier, it's nice to look at different types of examples where the wording is slightly different, and it just sometimes, if you're looking at something for the first time and you have no idea what to do with it because you haven't seen it before, it can become a bit intimidating. So show you a little bit of a different wording type of example. Let's look at this one. Okay, so this says to you that a large firm has established what it hopes is an objective system of deciding on annual pay increases for its employees. The system is based on a series of evaluation scores determined by the foreman for each employee. Employees with scores that are above 80 receive a merit pay increase. Those with scores, and I just want to highlight these. So let me okay. So those with scores above 80 will receive a merit pay increase. Those with scores, sure, not a problem. Those with scores between 50 and 80 receive a standard increase, and those that have a score below 50 receive no increase. Then it says that the firm designed the plan with the objective that on average, 25% of their employees would receive a merit increase, 65% would receive a standard increase, and 10% would receive no increase. Then it says after 1 year, the distribution of pay increases for 600 employees is shown below. So you then have the information in this table presented to you, which is always the FO figures. Sorry, that's super thick. So let me just make that a little bit thinner. low values. And then they say to you, test at the 1% significance level to determine whether this data indicates that the distribution of pay increases differs significantly from the proportions that were established by the firm. And they actually told you what the critical limit is here. It's 9.21%. So this was an easy one because we didn't actually have to go to table 3 of the appendix. But either way, even if you did have to, and I will come back to this, even if you did have to go to table 3 to get to the critical limit, you will see here that you would have got 9.21 anyway. But I'll come back to that in a second. Okay, so let's start off by writing out our null and alternate hypotheses. So your null hypothesis, remember from the question, they are testing whether, literally from the word proportion here, it's telling you that it's a test of equality of proportion. So your null hypothesis, test of equality of proportion. So your null hypothesis, remember the question is saying they want to test whether the distribution of pay increases differs from the proportion established by the firm, which obviously means that you're testing whether they differ or whether they are the same. So remember, differ and the same are the same as saying that they are equal or they are not equal. So in your null hypothesis, you will say that the distribution of pay increases is the same. So the distribution of pay increases is the same as the proportion established by the firm. Literally use the words that they gave to you in the question. That's exactly what I'm doing as well, just to show you that you don't even have to worry about trying to make up your own hypotheses here. You can literally just copy the wording from the question. And then, so this is saying that they're the same, meaning they're equal. So again, instead of the actual word equal, the word same means equal as well. It's just a synonym, another way for saying equal. So you can say the distribution increases is the same as the proportion established by the firm, and your alternate will literally say the opposite. So it will say that the distribution of pay increases differs. As the sorry, differs from the proportion established by the firm. Okay, so that's your null and alternate hypotheses done. Then your step 2 is to determine your region of acceptance and rejection. And now here, as I said, normally we would determine A, which is your level of significance, which they did say to you was 0.01. We established that here. So you would have had 0.01. And with a table like this, remember it's n minus 1 as your degree of freedom. There are 3 categories, so it's 3 minus 1, which would have been 2. And if you go to table 3 of your appendix, it's exactly the same values for both of the other examples we did. 0.01 going across, 2 coming down the first column, and either way, it would have given you the same critical limit that they told you to use here, which was 9.21. Okay, so this is your critical limit, but in this example, they actually gave that to you, so you didn't need to do this whole bit that I wrote down in the center here. Okay, so that was given to you. I just wanted to show you that either way, even if they didn't give it to you, you could have just got it using that information. So you just need to write this out in words, accept the null hypothesis if the chi-squared statistic is less than or equal to the 9.21. And that's it for your step 2. Now for step 3, your final actual calculation. Let's draw that up. Category FOFE. And then FO minus FE squared over FE. So your categories are merit. That was 193. Remember, that's from the table given. Then you have standard, 365. And then you have none, no increase, which is 42. Now for the FE values. They have given you percentages in these last few lines of that initial paragraph. This is where we're going to get the FE values from. They said to you 25% of their employees would receive merit increases. So you're going to take 25% and simply multiply it by your sample size, which they said to you there are 600 employees. So basically multiply it by your sample size, which they said to you there are 600 employees. So basically, and you don't actually need to show this working out, there's no marks for that. You're just going to say of the 600 employees, 25% of them will have a merit increase. So here, it's a little bit different to the one we were just working with just now, because that one just said that they were equally split. Here, they gave you percentages instead of just equally splitting them. So you multiplied 600 by 25, and that was 150. Then they said 65% of them would get standard increases, so 600 times 65, and that is 390. And then the last one was 10% with no increase, so 600 times 10%, and that is 60. Sorry, my pen moved there. Okay, so now your last column is as normal as always. It's the FO value minus the FE squared over the FE. So 193 minus your 150 squared over your 150. And that is 12.33. Then the next one is your 365. Is it 365? 56. Okay. 365 minus your 390. Squared over 390. And that's 1.60. And then the last one is 42 minus 60 squared over 60. And that's 5.4. I can just write that out here. So 42 minus 60 squared over 60. Okay, so now you're done with that. And all you're going to do is add up that last column. That's 19.33. And then look at where it falls on your diagram, which is somewhere here on the right-hand side. So this is your region of rejection. So now you're going to say, therefore, reject the null hypothesis. This is step 4 to say whether you accept or reject, and then go to your null and alternate at the top. If you're rejecting the null, that means you're saying that the null is not true. So put in an X at the null. That means that the alternate is true. And now literally just write out what the alternate is, that the distribution of pay increases does differ from the proportion established by the firm. So you'll say therefore the proportion of pay increases does differ from the proportion established by the firm. And that's it. All right, so please can I ask that you again go through the examples that we went through today, listen in on this video again, and the one that I had uploaded. Actually, there's two of them that I had uploaded to YouTube. I'll also make this one available on YouTube as well. Try out the examples again on your own. I'm also going to be uploading another revision worksheet for you together with this that I had done today. Please try it out on your own, test it out against the videos, and then also I'll upload the solutions to the other ones. And let me know if you're having a difficult time with anything. So this is the last learning unit. We're actually officially done with the content for the module. Next week will be our NSS session. I will send out communication just confirming and letting you know the exact date and time. It will definitely be our normal 6 o'clock session. I think it probably will be the normal Wednesday evening session next week, but I will just confirm that with you. I'll be going through a past paper as prep for your exam, and I will, as I said, just send out communication about that. All right. Thanks, Bradley. Enjoy the rest of your evening.